LLMs can actually do a lot more than just text generation, and in this video we're going to look at how to use an LLM to make a text classifier. And this has helped me automate a very mundane part of my job that has been super useful. And we're only starting to scratch the surface of what these things can actually do. I'm going to do this on a very small card with only 16 gigs of VRAM. And in order to be able to do that, we need to initialize and quantize the model in 8-bit. The reason we're going to be using 8-bit quantization and not 4-bit is that it's actually easier to train in 8-bit. As far as I know, the Adam optimizer has not been implemented in 4-bit yet. So this is a 3-step process. First, we quantize the model. Then we add a LoRa on top, and then we train with the LoRa. And this basically will allow us to use an LLM. I'm going to use Phi 3 Mini, but you can use Llama. You can pretty much use anything you want. And these are actually the best sequence classifiers that there are. So let's get started in code. At the top, we have all the usual import statements. So we're going to be using the transformers library with PyTorch, as well as the PEFT library, which is the parameter efficient fine-tuning, and NumPy as well. Basically, first we're going to define our quantization config, and here we're going to load it in 8-bit. We're going to define our model, which is Phi 3 Mini, and all we have to do to initialize an LLM as a classifier is called AutoModel for sequence classification. And what this is going to do is it's going to add a classifier head with the number of labels that we specify here on top. So we can basically, we're going to need to train it. We can't use it off the bat, but this is how we get our classification model from an LLM. And now we're going to define our LoRa config. The important part here is that the LoRa's, which are low ranking adapters that we can put on any model, allow us to train only the adapter and not the whole model itself. And this is much more friendly for small machines. LoRa's are meant to be trained on the linear layer of the self-attention module, and you have to know the name of the target module. In the case of Phi Mini, it's O_proj and the QKV_proj. And we're also going to define the modules to save, which is score, which is the name of the classification head. So that basically means that once we train this, we also want to save it. And we want the PEFT model, which is going to freeze the weights of the LLM and only leave the LoRa module as trainable. Well, we want it to leave the classification head as trainable as well. So this, we define simply the score, which is the classification head. And there you go. You have your base model. You prepare it for k-bit training, and you call get PEFT model with your base model as well as the LoRa config to get started. And the model, basically the model is defined at this stage. Next, we import the tokenizer, and we define the pre-processing function that's basically going to take our data set with the text label and tokenize everything. Here I want to truncate it, of course, and define the max length as 2048. This is to allow this to fit on my graphics card, which is only 16 gigs of VRAM, and you map the pre-processing function. And now we can get started. You do a small train test split, and after, if you examine the dataset, you see that the features are file, label, text, input IDs, and attention mask. The trainer only needs the label, input IDs, and attention masks, so file and text can be dropped. And if you examine this, you see that the initial model had 3.7 billion parameters, but only with the LoRa on top, less than 5 million are trainable. This has multiple advantages. The training is actually more stable because everything that the model has learned in its pre-training is not forgotten. And this makes for more stable training. And the second advantage is, well, it's much more friendly on small machines. So basically now we just define our data collator with padding. We define our training arguments and we define our trainer and we get to train. And now this is going to train a very custom text classification model using an LLM, which is obviously much better than the simple BERT or something a bit more simple. And this is a very powerful tool that can actually get you very, very far in automating mundane tasks.